Okay, now let's look at the theory part, the written questions. So the first question asks about the electrolysis of water, and you can see here as well that we've added some sulfuric acid. And the first question is why we've added that sulfuric acid, and the reason is it improves the conductivity of the water or of the solution. So you need that word conductivity in there really to get the mark. Secondly, name the gases collected in X and Y. So the setup here is a little bit strange. It's kind of an upside down electrolysis with the electrodes coming from the bottom. But these test tubes here you can see are used to collect the gas that's being made. So we just need to work out what gas is going to be produced. So we need to work out what electrode this is first. So this is at the positive electrode. So this is the anode, and then this is the cathode. And in water, plus our sulfuric acid, we've got these ions. We've got H plus and OH minus from the water. And then with the addition of sulfuric acid, we're going to get, well, more H plus ions. So that's the same. And then some sulfate ions as well. So at the cathode, we've only got H plus ions, which means that we're gonna generate hydrogen gas. So that's Y. So the answer for Y is hydrogen. And then at the anode, we've got hydroxide and sulfate, and the hydroxide is the one that's going to electrolyze, and that generates oxygen gas. So X will be oxygen. Moving on, we now need to write the half equation for the reaction that produces the gas in Y. Y was hydrogen, and we should remember that hydrogen in its element form is H2. So that comes from the H plus ions. Now, we've got an H plus ion there, but it's going to form a molecule, H2 of hydrogen. So we need two H plus ions. So we put a 2 there. And to make the H plus ions into H hydrogen atoms, we need to reduce them as electrons. So this one needs an electron, so does this one. So it'd be plus 2 E minus, 2 electrons. Finally, name a gas that may be used to sterilize water and then give a test. So sterilizing water will use chlorine gas. And the test for this is to use litmus paper. You can use blue or red, it doesn't matter. And the chlorine is going to bleach the paper. So we'll turn it white because chlorine is what makes bleach decolorize things. On to question 2. So this question is all about the extraction of aluminium. So we've got the normal setup here of the electrolysis cell for extracting aluminium. Question A, identify the element used to make the electrodes labeled H and G. Now, a few people wrote here graphite. That's not the name of the element. Graphite is, of course, made of carbon. So we had to write carbon there for that answer. B, which is the positive electrode. The positive electrode, a few people wrote anode, but it was asking for which electrode on the diagram is positive. And it's G, these ones at the top. The electrolyte L, so we extract our aluminium from aluminium oxide. And then L, the aluminium oxide is mixed with another substance. That substance is cryolite. I had a bit of issue spelling this, bit of a funny one, but it's spelled like that, cryolite. And the reason for that is it reduces the melting point. You had to say melting point because a few people wrote boiling point, but we're not boiling the aluminium oxide, we're just melting it. So the fact it lowers melting point is the important thing. Moving on, the name of the process that occurs at the anode. So at the anode, the oxide ions are turning into oxygen gas, and that means that they will lose electrons. And the name of that process is oxidation. And then the half ionic equation of reduction that occurs at the cathode. So at the cathode, the ions are the aluminium ions. They're 3 plus. How do I know they're 3 plus? Well, if you have a periodic table, and aluminium is in group 3, and group 3 elements always make 3 plus ions. And it's reduction, so we know we're going to gain electrons. And because it's 3 plus, to form the atom of aluminium, we will need 3 electrons because it's 3 plus, so we need 3 electrons to make the aluminium neutral. And then finally, explain why the anode needs to be frequently replaced, and include an equation in your answer. I would have accepted a word equation or a chemical equation. If we look here at E, I said that at the anode we're generating oxygen gas. Now that oxygen gas reacts with the electrode itself, which is made of carbon, and that makes carbon dioxide. So there's our equation, and then the second mark we kind of need to explain the electrodes. We can say disintegrates, or another phrase would be breaks down. Anything that gets the idea that the electrode starts to kind of wither away and becomes smaller and smaller until you can't use it anymore. On to question 3. So here we're looking at various different electrolytes and what they make at the cathode and anode. So the first one's been done for us as an example, and then we've got aqueous copper sulfate. So at the cathode, we've got copper ions, and we've got hydrogen ions. And we should remember that copper ions will they'll reduce before hydrogen. So if we look here, we're looking for the product. So we can say copper metal. You don't need to say metal, but put it in brackets. And at the anodes, carefully here. So we've got carbon electrodes. The cathode makes hydrogen. The anode makes chlorine. So if we kind of work our way backwards, we know if hydrogen gas is made, it's got H plus ions. If chlorine is made, we know we've got chloride ions. And then we look at the electrolytes, we can see that potassium hydroxide is formed. So that means that there must have been, at the start, OH minus ions and potassium ions. So looking at that, kind of working backwards and looking at that, those ions present. If there's H plus and OH minus, we know that it's going to be some sort of solution, so aqueous, and that solution is going to be potassium chloride. So there's 2 ways of kind of writing this. You can write aqueous potassium chloride, or you can write just potassium chloride solution. Onwards to the half equations. So all of these are positive ions, so they're all going to gain electrons. So these should all be plus. Mg2 plus, that's going to need to gain 2 electrons to make a magnesium atom. We've kind of done this equation before, so 2 hydrogen ions are going to need 2 electrons to make H2, and then copper 2 plus is going to need 2 electrons to make Cu, copper atom. Another question about substances formed. So it looks a bit strange, but we basically just got one big circuit, but we've got 2 electrolysis cells. So they're independent of each other, so they don't affect each other. On the left-hand side, we've got molten lead bromide. So let's work from P. P is the anode. So that's where the anion bromide will be, and that substance made will be bromine gas. It's really important when you write bromine that it's with an N, So that's the element, bromide is the ion. And then at Q, it's molten lead bromide, so we're going to get lead metal because it's not a solution, so there's no other hydrogen or hydroxide ions. And then R and S, we've got concentrated hydrochloric acid, so it's an acid as a solution, so we're going to get hydrogen and hydroxide ions. And then from the hydrochloric bit, we're going to get more hydrogen ions and chloride ions. You remember hydrochloric acid is HCl. So at the anode, we have to decide between hydroxide and chloride, and the halogen chloride will always be oxidized first. So that's going to make chlorine gas. And then at S, we've only got hydrogen ions, so we're going to get hydrogen gas. On to the final question about obtaining pure copper from impure copper. On this diagram, where's the impure copper? The impure copper is attached to the anode, so that's A. What is the substance used as the electrolyte? Because we're purifying copper, it needs to be some sort of copper solution. So copper sulfate is the most common answer. You could use copper nitrate as well if you wanted to. Explain why the formed sludge has economic importance. So that's C. So that C contains valuable metals because the impure copper we find at A here contains copper amongst other things, including gold, silver, for example. And that gold and silver, as the copper leaves the anode and travels to the cathode, this anode starts to break down and the gold and silver fall off and make this sludge at the bottom of the electrolysis vessel. So that's obviously got economic importance because these are valuable metals, so we can sell those. The copper metal is mostly used. Few answers would accept of this. The most obvious one would be wires or cables or electrical wiring, something like that. And then finally, does the concentration of the electrolyte D increase, decrease, or not change? So good question. It does not change because, we quickly explain, at the cathode, we've got this equation going on. The copper ions are being reduced and making copper. So in that way, the concentration of copper ions is going down, but that is counteracted by the process that's going on at the anode. So at the anode, what's happening is the copper is being oxidized to make copper ions. And those copper ions, they enter the solution and then they'll travel across. So in that way, the concentration of copper ions is being increased, and that process balances out this process. So overall, there's no change in the amount of copper. There's copper being produced, copper being used up, but it's being produced and used up at the same rate, which means that there's going to be no change. And so for the change of the anode with aqueous copper sulfate, you'll notice here that the electrode is copper. So this looks like a setup for electroplating. And what that means is the copper, which makes up the anode, that's made of copper, will be oxidized. So this process happens, copper forms copper ions. And so the change of the anode, a couple of things you can say. You could say copper ions formed. Or you could say there's a decrease in maths. Either would have been okay.